The afternoon. So let's do that again. Good afternoon, Year 3, and welcome back to Professor Williams' laboratory, where today you are going to be doing an experiment all about shadows. So without further ado, I'm going to share my slides so that you can see exactly what we are doing. So today we are going to be learning about how proximity of light source affects shadows. So again, just to repeat that again, how the proximity of a light source affects shadows. When I'm talking about proximity, which is going to be one of our keywords today, I'm talking about the closeness. So how close a light source is to an object affects its shadow. Right, so I hope you've remembered lots of the learning that we did last week, because I am now going to test you. Quick recap. I'm going to read you the question, then you're going to pause the video, answer the question, shout it out, and then continue. Are you ready? I hope that was a yes. So, question number 1. What type of object allows some but not all light through it? Is it A, transparent, B, translucent, or C, opaque? Pause the video and answer the question. The answer was B, translucent. Hopefully you got that correct. Translucent allows some but not all light through it. Question number 2. What type of object does not allow light through it? What type of object does not allow light through it? Is it A, transparent, B, translucent, or C, opaque? Pause the video and answer that now. The answer was C. Opaque objects do not allow any light through it. That's why they cast a shadow instead, because it's blocking the light. Next question. Let me just hide this. What type of object allows the majority of light through it? So it allows most of the light through it. Is it A, transparent, B, translucent, or C, opaque? Pause the video and answer the question. The answer is A, transparent objects allow the majority of light through. Question number 4 is a question from one of our previous units, which was on rocks. If a rock is durable, so I'm going to read that again, durable. If a rock is durable, that means it is A, brittle and weak. Brittle means crumbles apart easily. B, strong and hard-wearing. Or C, absorbent. Pause the video and answer that question now. The answer was B. If a rock is durable, that means it is strong and hard-wearing. Hopefully you got that correct. If not, then maybe you can have a quick recap of rocks and durability. So, moving on, I'm going to go through some of our star words today that we're going to be using. The words in red are words that we should already know, and the words in blue are words that we're going to be talking about today. So the first word is emit. Emit. So I'm saying the word, you repeat it after me. Emit. Fantastic. Emit means to give out light. For example, the sun emits light. Emit can also mean to give out anything. It can give out heat. The sun emits heat. Fire emits heat. Okay, the next word is light source. A light source is an object that emits light. So we're using two of the keywords together. A light source is an object that emits light. Okay, now when you talk about objects and their relationship to light, there are 3 different words that you are going to be looking at. An object is either translucent, and that means it lets some but not all light through. Transparent. If an object is transparent, it lets most of the light through. Or the object will be opaque. And that means the object does not let any of the light through. It blocks the light. So today we are going to be looking at the proximity of light source to an object. Proximity means the closeness in space. For example, those 2 marbles in the picture are in close proximity to one another. Defined. And that just means something you can see clearly or with a clear outline. Moving on. So today we are looking at shadows, and we are going to be exploring shadows, and we are going to be creating shadows. And we're going to be writing up about them, because we are going to be writing up an experiment all about shadows and the proximity of a light source to an object and how that affects shadows. But just to recap, shadows, when a light from a source is blocked by an opaque object, a shadow is formed. So if you have a light source, let's say the sun, and the object here in this case, well, looking at the shadows, I can actually tell what the object was. It was people. So I can see this is a person, and together they are people. So the light has hit the people. They are blocking the light, which is now causing a shadow. Now, usually clear defined shadows, you can tell because the people are opaque, they're more clearly defined. When light passes through a translucent object, it also forms a shadow, but the shadow is simply less defined. It's not as clear and it's not as solid as the shadows formed by opaque objects. My next question for you at home is, can transparent objects form shadows? Can transparent objects form shadows? Pause the video so that you can answer that question. Now, hopefully you got the correct answer, which is transparent objects cannot form shadows. And the reason why they can't form shadows is because when a light source shines on a transparent object, the light source travels through the object. Okay, it's not blocking the light, so therefore there cannot be a shadow cast. Now, we've got two pictures here, two shadows formed by the same person, same light source, but somehow the shadows look a bit different. I would like you to look at the shadows carefully, compare them. What's the same? What's different? Pause the video now so that you can do that. Okay, I have had a compare of these shadows, and looking at them, I can see that this shadow is much longer in comparison to this shadow here. And I know this man hasn't got legs that long because that's simply impossible. So it must be the shadow, it must be to do with the light source. This shadow is also less defined. This shadow I can see very clearly, it's solid, it's darker. This shadow seems slightly less defined, slightly lighter and longer. In comparison, this shadow is very clear. It's much clearer than the first shadow, and it's actually shorter. This looks closer to what I imagined the size of this man would be. But both shadows show an image of a person. And if both of these people are outside, my question for you is, what is the light source that is causing this shadow? What light source is hitting the person that is causing the shadow? Think about it as they're both outside. Hopefully you realise that it is the sun that was the light source. My next question is, why do you think this might be? Why do you think, even though they both have the same light source and the same object, so the sun, it's both the sun and it's both a person, why do their shadows look different? Pause the video and have a good think about why the shadows might be different and say your answers out loud. Okay, thank you for that. I'm not going to tell you why they're different because that is what our experiment is for. Very, very exciting. We are going to be doing a shadow proximity experiment. We're going to be testing shadows and seeing how they differ and what is actually causing them. For that, what you need to do is make sure you have a pen and paper ready. You might want to pause this video until you get that. Get a pen and some paper. Pause the video. Fantastic. Now that you've got a pen and paper, first thing you need to do is write out the title and equipment list. Our title is, how might the proximity of the light source affect the shadow? How might the proximity of the light source affect a shadow? And that's what we are exploring. So pause the video and write the title down. Fantastic. The next thing you will need is a light source and an object. So we're writing our equipment list now just to tell, if we were to repeat this experiment again, we can see what we need to get. We're using a light source and an object. If you're at home, you might want to specify what the object is and what the light source is. For me, it's going to be my phone light, which is a powerful light. You might have a torch, you might have a lantern, you might have a lamp, things like that. My object is going to be a cup. Okay, so you can write down what your object is. I don't know what your one is. If you haven't got objects or a light source at home, then I'm going to show you my experiment and you can write that up as yours. Pause the video so that you can have time to do that. Fantastic. Moving on. So now that you have written down the title question and the equipment list, you need to write down your prediction. I'm just going to make this slightly, there we go. So you need to write down what you predict. And before you write down your prediction, let me explain what we're going to be doing in this experiment. I'm just going to stop sharing my screen for just a moment so you can see. So in this experiment, I am going to be holding a light source over an object. So let's say this is my cup and this is my light source, which is my foam. Let's make sure the light is on. You see that? I am going to be holding the light source over an object and it's going to cast a shadow. I am going to be holding, the proximity of the light source is going to change. So first I'm going to start off at close proximity, so very close to my light source. Then I'm going to hold my light source at medium proximity away from the object. And then I'm going to hold my light source at a distance from my object, so quite far away from my object. And I'm going to test and see and record my observations to see how the shadows change as I move my light source further and further away. That is what the experiment is going to be testing. So now that you understand what we're going to be doing, what you need to do is write your prediction. So I'm going to reshare my screen again. Now you need to copy out this sentence at home or in your books. I predict that when the light source is higher or lower, you need to choose one, the shadow will become more defined or less defined, and longer or shorter. Just to read that out again for you, I predict that when the light source is higher or lower, choose one, pardon me, the shadow will become more defined or less defined, you need to choose the correct option, and longer or shorter. Pause the video so that you can write down your prediction now. Great work. You've written down your predictions, your title, your equipment list. I'm going to get you just to write down, before I go on to the instructions, actually, it might be easier if you write down, get this ready so that you can write down your observations as soon as we begin. So what you need to do is you need to create 3 sections. The first section is going to be close proximity. Make sure you leave about 3 lines if you're using lined paper in between. If you're using blank paper, just leave some space in between. Close proximity, then do a dash. Make sure you write proximity and observations. Then write medium proximity, do a dash and then leave some space. And then write at a distance and leave some space. Pause the video so that you can get this copied out. Great work, fantastic. Now that you've done that, I can explain our experiment and we're going to follow the instructions and then we're going to do it. So first thing you need to do is hold your light source directly above your object. You are going to record 3 observations. Your observations will detail what you notice about the shadow as the light source moves further up from the object. So if you're doing this at home, you don't need to watch you might want to watch the rest of the video and watch me do it, or you can begin. I showed you close proximity. You need to hold the light source close, directly above the object. Then move it slightly further away and record your observations for medium proximity, and then hold your light source at a distance and record your observations of what you notice about the shadow at a distance. The shadow is going to change, okay? Some shadows are going to be more defined, some are going to be unclear. Some might be short, some might be long, but depending on the object, some of your shadows might be smaller, some of your shadows might be bigger. If you're at home, you can pause the video so that you can actually carry out your experiment. If you're at home and you want to watch me do my experiment and you want to record your own observations on my experiment, then keep watching because I'm going to show you that now. Okay, so let's switch my camera. Fantastic. Okay, so here I have a light source. My light source is a cup. Sorry, light source? Here I have my object. My object is a cup. I also have a light source. My light source is my phone. The first observation we are going to record is holding the light source at close proximity to the object. So I'm going to hold the light source at close proximity to the object. What do you notice about the shadow? You can pause the video now and write what you notice about the shadow. Great, so you should have filled in this section here on close proximity. I'm now going to move on to medium proximity and you are going to record your observations. What can you see about the shadow? Is it defined, unclear, bigger, smaller, more solid, less solid? Okay, let's record your observations for medium proximity. This means I'm going to move slightly further away. So I'm going to move slightly further away. What do you notice about the shadow? Okay, I'm holding my light source above it. What do you notice about the shadow? Pause the video so you can look at the shadow in detail and describe it. Pause the video now. Fantastic. I'm just going to reshare my screen. You should now have filled in the medium proximity and described the shadow. I'm now going to complete the last variant, which is at a distance. I'm going to be holding my light source at a distance. You need to record your observations. So bear with me. Stop sharing my screen. Now, for this, I'm just going to hold the camera slightly higher. Here, I'm holding the light source at a distance. What do you notice about the shadow? Is it more defined, less defined, bigger, smaller, longer, shorter? Pause the video now so that you can describe what's happening to the shadow of the cup. I'm just going to switch back. You should now have filled in at a distance. We've looked at the shadow. So we looked at the shadow when the light source was held at a distance. Pause the video so that you can complete that if you haven't. By now, you should have finished your experiment. The last thing that we need to do is copy out this. My experiment showed me that the light source moved further up. Sorry, my experiment showed me that as the light source moved further up, the shadow became, you need to fill in the missing word here. What happened? Then you need to tell me if it was similar or different to your prediction. So go back to your prediction, and then you can complete this section. This was similar / different to my prediction. Which one was it? Similar or different to your prediction? I'm just going to read that again. My experiment showed me that as the light source moved further up, the shadow, sorry, let me do that again. My experiment showed me that as the light source moved further up, the shadow became, this was similar or different to my prediction. Pause the video so that you can complete that. Okay, fantastic. You have reached the end of our lesson and hopefully you were able to learn something about shadows and how they are affected by the proximity of the light source. Thank you for joining Professor Williams in my laboratory. Laboratory? That's the toilet, absolutely not. In my laboratory, and I will see you next week in next week's lesson on Friday. Bye, you three.